it can be of common confusion to think that something like x squared times y to the third would be, a lot of people would start to do something like this, like xy to the fifth power. Well, that's not okay. We can't really do that because that's not what this is saying. We're not multiplying x times y, x times y, x times y, x times y. What this means is x times y times y times y. And our goal with exponents is to simplify it so that we don't have so many common multiples floating around. But in this case, all I can do is I can say, well, I have x times x, which is x squared, y times y, which is y to the third. So I don't really have x to the fifth or y to the fifth or xy to the fifth because these are different bases than these. So this is a point on which to be really, really careful. Now, a really quick extension would be something like this. Let's say that you have x squared to the third power. Well, again, some people get confused because they think, well, do I add, do I multiply, what do I do exactly? Well, we know that on the inside we have x times x, but we're saying take this entire base, this entire thing in parentheses, and multiply it by itself 3 times. So on the outer end, what we have is x squared times x squared times x squared. Now the reason I'm just using parentheses is just to show that I'm repeating this thing 3 times. But realistically, this just means x squared times x squared times x squared, which we already know that I have x times x times x times x times x times x, which means I'll have x multiplied by itself 6 times. So a lot of people will see, oh, okay, well, that's just the product of the 2 here and the 3 here. And that definitely does apply. So if I had 4 squared to the 5th power, well, that means 4 squared times 4 squared times 4 squared times 4 squared times 4 squared. And you can see this kind of gets to be a pain, which is 4 times 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 4. Well, how many times am I multiplying 4 by itself? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And, this should be 4 raised to the 10th power, which is the same thing I would have gotten if I had just multiplied. So we're going to add to our rule here, which basically says that if I have x raised to the a power, and that entire thing multiplied by itself b times, then I can actually multiply the exponents together and come up with x to the a times b. One last example to be really cautious about is what if I had something like 4x to the third squared? Okay, well, let's just carefully again write out what this means, because now we have this extra coefficient of 4 in here and the x to the third. So this means 4 times x to the third times 4 times x to the third. Well, we already know that we can multiply those coefficients because the order of operation doesn't matter. So that would be 16. And x to the third times x to the third is x times x times x times x times x times x, which is x to the 6th power. And so in this case, well, what did I do? I not only had to multiply the exponents here, in other words, x to the third multiplied by itself twice, but I also had to do 4 times 4, which is 4 squared. So be careful that you square everything inside the parentheses. So one easy way to write this out would be 4x to the third squared would actually come out to 4 squared times x to the third squared. 4 squared is 16. X to the third squared, by our property, would give us x to the 6th power. As one final example, let's say 11x to the 4th all raised to the 2nd power. So similar process. 11 would get multiplied by itself, and x to the 4th would get multiplied by itself. 11 squared, or 11 times 11 is 121. 4 times 2 is 8, so I would get 121 x to the 8th power. So now we've dealt with exponents a little bit. Let's mention the idea of a square root and cube root. So a square root would allow us to answer a question like this. Solve x squared equals 4.